A very important topic of logic is truth tables. Now, truth tables, they're going to be used to determine if a compound statement is true or false, and it consists of all possible arrangements depending on the variables that we're using. So if you have two statements, we'll represent those with a P and a Q. These are your possible combinations to start with, or your possible truth values, in other words. And here's the way you get this, in case you're wondering. Let's say you're taking a true-false question or exam, something like that, and you just got two questions. And you're just going to guess. So you got two questions on a true-false quiz, and you're going to guess. So you could guess that the first question is true. Now, if you guess the first question is true, that means you could guess the second one is true, or the second one is false. So here we have two pairs of guesses: true, 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 false. Or you could also guess that the first question is false, and the second one is true. Or you could guess the first one is false, and the second one is also false. So what we're doing is we're just listing the possible combinations or arrangements for our two-question true-false exam. True, 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 false, false, true, false, false. That's where those come from. Now, in turn, it could be a three-question true-false exam. So the first question you could guess true, or you could guess false. Now, the second question, let's say in the first question you guess true, second question you could guess true, or you could guess false. So let's assume that on the first question you guess true, second one you guess true, then the third one you could also guess true, or you could guess false. In other words, all you're going to do is just keep on branching these down until you have three different questions accounted for. So this is like question 1, this is question 2, this is question 3. So if you guess false in the first one, second one could be true or false. And if you branch these off, you get true or false for all those. So you're just extending the branches with true and falses. And if you're wondering where these come from, they come from true, 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 just following the lines down, or true, true, false, or true, false, true, true, false, 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 true, true, false, true, false, 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 true, and false, false, false. That's where those come from. It really isn't a magic secret. It's just thinking of three true-false questions and just guessing. That's what it comes down to. Now there's some really, really important information. Now this squiggly does mean not. This upside down V does mean and this V means or. This one-sided arrow means if then, and the double-sided arrow means if and only if. Now what we're going to talk about is very, very important. We're talking about true and false statements. So if P happens to be a true statement, then this squiggly P means it's going to be a false, and vice versa. Now this P and Q, that's how I'm going to read it, P and Q. What you need to remember about this is it's only true if both P and Q are true. An example I like to use is if you're interviewing for a job or applying for a job, it requires, for example, a degree and experience. Degree and experience. Now, in order to apply, you have to have the degree and experience. So if you have both of those, if both of these are true for you, then you can apply. So it's true that you can apply. Now if you only have one of these or none of these, then you can't. So it's a false condition for you to apply. Now this or is true when either or is true. So let's think about if you have the degree, or the position requires degree or experience. So if you have either or, then you can apply. The only time you can apply is if you have neither, or if both are false. So if you have the degree, then it's true you can apply. If you have the experience, it's true that you can apply. If you have both the degree and experience, then it's true that you can apply. If you have neither, then it's false that you can apply. Now, this P, if P then Q, it is true in every single case except when it goes true to false, when P is true and Q is false. Now, the example I like to give, you may not like too much, but it's like it says if you earn an A, then you get a car. If an A, then I'm going to give you a car. Now, if you do make an A, I'm going to give you a car. I'll give you a car. That's a very true statement. Now, if you get an A, then I don't give you a car, then I lie to you. So that's a false statement. Now, if you don't make an A and I give you a car, I didn't lie to you. That's a true statement. I didn't say anything about not making an A. I can still give you a car if I want. And if you don't make an A, I can also not give you a car if I want. That's not a true. That's not a false or a false statement. It's a true statement because I didn't lie to you. The only time I would have lied to you is if you make an A, then I don't give you a car. Not the easiest thing to realize, but that's an example to think of. Now, if and only if P, if and only if Q, this one is pretty much easy to remember if you just know that if P and Q have the same truth values, then it's always true. So none of this may make any sense, so I'm going to condense it for you with this summary. Now the squiggly, the not P, it's just the opposite of the truth statement that's given. Now, this or, it's false only if both are false. The and is true only if both are true. And the one-sided arrow, the if then, is false only if true then false. And the double-sided arrow, the if and only if, is true only if both are true or both are false. This is probably the best way to think of it. Or is false only if both are false. And is true only if both are true. And then the if then is false only if true false. And if and only if is true if both are true or both are false. So we're going to use this information to construct truth tables. Now what we're going to do with truth tables, for example, with this statement that has both a P and a Q, we're going to start out with their possible truth values for P and Q. True, 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 false, false, true, false, false. That's standard. Now what we're going to do is add columns so we can find out what this truth table is for, or the truth values are for this final statement, this squiggly P and Q. But before I can do that, I need to break it down into different pieces. So if you look, I already have the Q right here, so I'm not going to do that again, but I don't have the squiggly P column, so I'm going to use that. I'm going to make a squiggly P column. Now, since I already have my P, true, true, false, false, squiggly P means I just change all those to false, false, true, true. So I went from true to false, false to true, false to true. Now I'm going to do, oh, I didn't need that one. Don't make an A. It's not an A. Now I'm going to do my truth values for the statement that I'm really concerned about, not P and Q. So let's look at not P and Q. We have false and true. Well, just think about this for a second. Here's the easiest way to think of it. If it's an and, it's only true if both are true. So this condition right here is the only place where not P and Q are both true. So that's a true. And everything else, if it has a false statement, then it's going to be false, no matter what. And that's the easiest way to approach it, is with this information right here. Let's do this one. This one has P, Q, and R, so that's why I have my three possible combinations. So what I'm going to do first, I'm going to break it down, finding P or Q first, and then I'm going to use that truth table, or that truth column, to find the answer column, is what some books call it. And if you remember what I wrote down, and I'll go back up to it here in a second, P or Q is only false if false and false. See that? Or is false only if false, false. So I'm going to look at the PQ column, and any words that have false, false, that's what I'm going to use. That's what I'm going to put false there. So PQ only. So I have false, false there, and false, false there. So that means that's going to be false, and that's going to be false. Everything else is going to be true. Once again, to find this column, I'm only looking at the PQ columns, nothing else. So one way you could think of this, some book like to write columns or numbers to show you that you're doing 1, 2, 3, 4. This is the order you're doing them. So our last column, the fifth column, will be our truth tables column, or answer column. So what that means is to find the truth column, the truth values for this fifth column, we're going to take the P or Q column, which is 4, and we're going to do an AND with the R, which is the third. So we're going to do, you can think of it like this maybe, the fourth and the third together. So we're just looking at these two. See, it's a lot easier to break it down like this than it is to think about all three at once. So this fourth column is making these two into one. So now we can look at the last, or for our fifth column, the answer column, we just look at these two columns. And this is, well, we're looking at P or Q with the R, so 4 with the 3. And so this is our AND. The main thing is we're doing the AND on these two columns, because that's their AND. Just like doing the fourth with the third, fourth with the third, fourth with the third, doing the AND. And remember, AND is only true with when if they're both true. So here they're both true, so put a true here. Here they're both true. There we had a false. There we have a false. There we have a true. There we have a false. I mean, the one before we had both true. There we have a false, and the last we have a false also. So let's go over it again. These two were both true, so it's true. This one had a false, so it's a false. These two are both true. This one has a false, so it's false. This one has both true, so that's true. The last three have at least one false, so those are all false. And that's it. So once again, very, very important. Let's do some examples. So we're going to do if Q, then P. So when you look at this, you're actually going to look from Q to P. And also take note that the if then statement is false only if true then false. So since this is true to true, that's a true statement. Since that's false to true, that's a true statement. But notice here, this goes from true to false. Remember to go in this direction. True, right to left. True to false. And that's the only time where an if then statement is false. And false to false is true. So make note. This means go from Q to P. So when we go from Q to P, true to false, that's the only time that if then is false. And that's the only time we have our if there. And everything else is going to be true. Now on this example, I can't go straight from P to if and only if Q, because I have a squiggly P. So what I'm going to do first is find this values, the truth values for squiggly P. Now if P is true, true, false, false, that squiggly means the opposite, or the not. So instead of true, true, false, false, it's going to be false, false, true, true. So now I can do my squiggly P with a two-sided arrow Q. So it's not P if and only if Q. And recall that this is true if our truth values, if both truth values are the same, either both true or both false. So what I'm looking at this column. Let's call it 1, 2, 3. So I'm going to look at column 3 with column 2, or 2, 3. So these two right here are what we're looking at to find this fourth column, the answer column. So if they're opposites, it's false. These are the same, so it's a true. These are the same, so that's a true. These are opposites, false. Once again, when you're doing the if and only if, this is if and only if is true if they're both true or both false. So false false is a true statement. True true is also a true statement. Otherwise it's false. And that's it.